For our Chapter 2 extension section, we're looking at symbolic logic. So we're going to take those conditional statements we looked at and that formula for conditional statements determining their truth value. We're going to take these ideas a few steps further, look at some new concepts also in addition to if-then statements and their alternatives like the converse, inverse, and contrapositive. So two different ways that we can link data pieces together is a conjunction and a disjunction. A conjunction with this upside down V links two pieces of data with the word and. All right, so P and Q. Now for conjunction to be true, both pieces of data must be true. So for example, your parents want you to clean your room and do the dishes. When are they going to be happy? Right, your parents are going to be happy when you have cleaned your room and you have done the dishes. Both of those things need to be true for the overall conjunction to be true. We have a disjunction with a big capital V. That links two pieces of data with the word or. Now, with or, at least one piece of data must be true for the disjunction to be true. So think about your parents saying, look, we want you to clean your room or do the dishes. They're going to be happy when you've done one of them, when you have cleaned the room or you have done the dishes. And if you do both, then that's just extra brownie points that you can cash in on later. Okay? So conjunctions with and, disjunctions with or. The way I always remember it is the upside down V is kind of like a roof, and it goes over the two pieces, P and Q. Both of them must be true. The disjunction, the V is like a wedge, driving P and Q apart, separating them, either one. So to look at some examples in a truth table, the truth table, of course, gives you all the possible combinations. We have two pieces of data, P and Q. We're going to have to fill these columns in. So our first piece of data, half true, half false. Our second piece of data is every other, true, false, true, false. So now we're going to fill in the subsequent columns, looking at the piece, looking at how these pieces of data are related to each other. So we have the upside down V, that is and both pieces of data must be true for a conjunction or and to be true. So if we look, we have two trues. Both of them are true, so the conjunction is true. In our next row, we have a true and a false. Only one of them is true, so the conjunction is false. In our third row, a false and a true. One of them is false, so the conjunction is false. And in our last row, they are both false, so the conjunction is false. You did not clean your room, you did not do the dishes, and you can now do nothing fun for a while until you do what your parents want you to do. The disjunction, the right side up V, that is or. So we only need one of them to be true. If either P or Q is true, the disjunction is true. If they're both true, that's at least one as well. So in our first row, they're both true. So the disjunction is true. In our second row, P is true, Q is false. But a disjunction says at least one piece has to be true. So this is true. We have a false and a true. That's true. And then finally we get to two falses. So clean your room or do the dishes. You scream at them no and you run outside. Your night is not going too well. That disjunction is false. All right? So conjunction, both need to be true. Disjunction, at least one. Now let's make it a little interesting, okay? And I'm going to actually make a little edit here. Put parentheses around the conjunction, P and Q. So what we're going to do to fill out this more complicated relationship is we're going to look back at our previous columns to look at true and false values. So because we already built the P and Q column, we can reference this column for P and Q. So P and Q is true in the first row. P and Q is false in the second row. P and Q is false in the third row, and P and Q is false in the fourth row. So by building that column, we can quickly fill out that final relationship. Now our second piece of data, P, we're going to copy down the truth values from the P column. So half true, half false. So now, overall, what we're evaluating is a conditional statement. If P and Q, then P. If P and Q, then P. Now, a conditional statement is only false with a true hypothesis and a false conclusion. If true, then false. So we look here. We have if true, then true. That is a true conditional statement. If false, then true. That is also a true conditional statement. If false, then false. That's a true conditional statement. If false, then false. That is a true conditional statement as well. So, filling out these more complicated tables, there's only one way that this gets more in depth. Okay? Let's say instead of 2 data values, we have 3. Now we want to create all the possible combinations. Okay? When you only have 2 pieces of data, there are 4 total combinations. That is 2 to the second. Because you have 2 pieces of data, and they can be tallied up in 2 different ways, true or false. So 2 to the second, we have 4. Now if you have 3 data pieces, all right, well, those 3 data pieces all have a true or false value to them. So you have a true or false value playing out 3 times. So we actually have 8 combinations total. So I need a few more rows. And here's how we can easily fill that in. No matter what order your data piece is in, whether alphabetical order or out of alphabetical order, what you want to do is you want to look at your first data piece, your second, and your third. Your first data piece, however many rows you have, half of them are true, half of them are false. So we have 8 combinations total, so we have 4 trues and 4 falses. So every 4, it alternates in your first data piece. Your second data piece will alternate twice as often. So twice as often, or double the amount of switching back and forth. So we had 4 trues and 4 falses. Now twice as often, it'll be every 2. So 2 true, 2 false, 2 true, 2 false. Your next column, your third data piece, will alternate truth values twice as often as the second. So it was every 4, then it was every 2, now it's every 1. That's how you can easily start any truth table. How many data pieces do you have? How many different letters? And then 2 to the power of how many letters you have. So if you have 4 letters, 2 to the 4th power, 16, you'll have 16 rows. The first data piece, half true, half false. So 8 true, 8 false. The next one, twice as often. 4 true, 4 false, 4 true, 4 false. The next one, twice as often, 2 true, 2 false, 2 true, 2 false. The next one, every single other. So that is symbolic logic, conjunction, disjunction, and kind of some truth tables on steroids from what we've been seeing.